Assalamu alaikum. We know when a vector is multiplied with another vector, it gives either a vector or a scalar quantity. If the product obtained is a vector, then it is referred as vector product. In this video, we will discuss some of the properties of vector product. The vector product obtained is always found to be acting perpendicular to the plane containing vectors. Suppose this is a vector multiplied with another vector acts along this direction. Then the product of these two, if it is a vector, then it will act perpendicular to the plane containing vector A and vector B. Let's take the angle between these two as theta. Here, to make it little better to understand, I take the vector product as vector C. Now, it just acts perpendicular to the plane containing vector A and vector B. And here, one more thing you need to remember is, it is not necessary for vector A and vector B to be acting perpendicular to each other. Okay. What is this plane? You can take the surface of this board as a plane. If these two vectors act along the plane of this board, then the product will be acting just along the direction of this pen. Here it makes an angle of 90 degrees with the surface of the board. Here it is not possible to draw a line which is protruding outward. So I have drawn a line along this direction, which is just perpendicular to the plane containing A and B. Fine. Now, second thing you need to know about the vector product is, they doesn't follow commutative law. What is this? They doesn't obey commutative law. Commutative law. What is this commutative law? Suppose I have vector A cross vector B, then it will not be equal to vector B cross vector A. Clear? Whereas vector A cross vector B will be equal to minus of vector B cross vector A. But here you need to remember one thing, that if I take the magnitude of these two, then they will be equal to each other. Modulus of A vector cross B vector, which represents the magnitude of vector A cross vector B. Okay, it is found to be equal to the magnitude of vector B cross vector A. Understand? So, when the vector product will have maximum value, let's find out. If the angle between two vectors is 90 degree, if a vector A and vector B are perpendicular to each other, then the product of these two will have maximum value. Here, vector A cross vector B will have maximum value if sin of theta is equal to 1. When we will have sin of theta is equal to 1? If theta is equal to 90 degree, then its value will be equal to 1. Okay. So when vector A acts perpendicular to vector B, we will have maximum value of a vector product. Okay. Next, when it will have minimum value. When vector product have minimum value. See, vector A cross vector B will have minimum value if the angle between vector A and vector B is either 0 or 180 degree. If theta is equal to 0 degree or it is equal to 180 degree. Why is it so? The reason is here vector A cross vector B is equal to AB sin of 0. Here sin of 0 is what? It's nothing but 0. So you get a 0 as a value. Okay. In a similar way, sin of 180 is also 0. So we get the minimum value for the vector product in this case. So this clearly shows that if the vectors are parallel or anti-parallel, in both the cases the value obtained is 0. Okay, they are parallel or anti-parallel. In both the cases, here the angle is 0 degree and here the angle is 180 degree. In both the cases, the value obtained is minimum, that is 0. Okay. Next, let's find out what happened when a vector is multiplied with itself. Suppose I have vector A. If I multiply it with itself, then what value I will get? Let's find out. Here, how to expand this one? Here, this two are expanded in this manner. I take a modulus of vector A. It is multiplied with modulus of this vector. This is again modulus of A vector. Then I take sine of angle between them. This is a theta here. Clear? Then what is the angle between these two? Here both are acting in the same direction. So the angle between them is nothing but, here modulus of A vector is A. Modulus of A vector is again A. Here the angle between these two is 0. What is sin of 0? Sin of 0 is 0. So we get A multiplied with A multiplied with 0 equals to 0. This clearly shows that the self product, the self cross product is equal to 0, which can be represented as a 0 vector. In physics, 0 vector is represented as 0. What is a 0 vector? 0 vector is nothing but a vector whose magnitude is equal to 0 and the direction is unknown. Why it is unknown? There is a reason behind it. Here, 0 vector ends at a point from where it starts. Okay, so ending point and starting point both are same. So it is the direction is unknown. Now another property, the sixth property of this. Now by keeping this in mind, now if we apply this self product to unit vectors, then we'll see what we get here. I, j and k are unit vectors. I cap is a unit vector acting along x axis. J cap is a unit vector acting along y axis, and k cap is the unit vector acting along z axis. Okay, when I cap is multiplied with I cap, what will we get? We get this. I multiplied with I. No, this is the magnitude. Or let me take it this manner. Modulus of I cap, modulus of I cap, and sine of angle between them. Both act in the same direction. So the sine is, the angle is 0. Here, the magnitude of unit vector is nothing but 1. 1 multiplied with 1. Here, the sine of 0 is what? It's nothing but 0. So it is multiplied with 0. What we get is 0. In the similar way, j cap cross j cap is also 0, and k cap cross k cap is also 0. So this clearly shows that self cross product is always a 0. Okay. Now, what about orthogonal vectors? What is this orthogonal vector? Unit vectors which act perpendicular to each other are referred as orthogonal vectors. Suppose I have three axes, x-axis, y-axis and a z-axis, which act perpendicular to each other. Now already I have told you here this cross line actually represents a line which projects outward from the surface of the board. It is not possible to draw a line which projects outward. So we draw a line inclined to y-axis and z-axis. Understand? So in this way, the unit vector which acts along x-axis is I cap. The unit vector which acts along y-axis is j cap, and the unit vector which acts along z-axis is nothing but k cap. Okay. Now let me take the cross product of this orthogonal vectors. If I take the cross product of I and j, I cap cross j cap, then I will get a k cap. The similar way, when I multiply k cap with I cap, I will get a j cap. Clear? The next, when j cap is multiplied with the k cap, I will get a I cap. Now, how to remember this? This can be remembered easily using right hand screw rule. Okay, just you follow. Let's move in anti-clockwise direction. Let's go in the anti-clockwise direction. In a direction opposite to the direction in which hands of the clock move is called as anti-clockwise direction. Anti-clockwise direction. Anti-clockwise direction. Okay. So I go this way. When I and j are multiplied, we get the k cap. When k and I are multiplied, we get the j cap. When j and k are multiplied together, we get I cap. So it's obvious. Okay, from the diagram. But what happens if we reverse it? Let's find out. Now we know cross product do not follow commutative law. So on reversing it, if I reverse j cap, I multiply j cap with the I cap. The cross product of this two gives me minus k cap. In similar way, I cap cross k cap gives as minus j cap. The next k cap cross j cap gives us minus I cap. Now let me give the cross product of the components of two vectors. Now suppose I have vector A and vector B, and I want to find out the cross product of these two vectors. Then vector A is split into its components as ax I cap plus ay j cap plus az k cap. Here ax is the component of vector A along x-axis, ay is the component of a vector along y-axis, and az is the component of a vector along z-axis. Okay, then I'm going to multiply this with vector B. So I will split the vector B into its component as bx I cap, by k j cap, and bz k cap. Now look at this carefully. How do I am going to get the cross product of vector A and vector B based on their components? Okay, for that I write vector A cross vector B. Then I take a determinant of the components. Here the equal terms in both are nothing but I cap, j cap and k cap. So it is taken along the first row. Then the components of V are taken along the second row. Ax, Ay and Az. Then in the third row I take the components of vector B. Bx, By and Bz. Now look at this carefully how I am going to expand them. Expansion of this. What I do? I start with the first component, first thing present here in this determinant. That's I. When I take I have to leave the row in which it is present. The same way I have to leave the column in which it is present. Okay. When I leave these two, what left here is nothing but these four components. So they are multiplied in this way. Ay multiplied with the Bz. We have to go this way. Ay multiplied with Bz. Then minus, what I do now, I multiply in this way, in this direction. Az is multiplied with the By. Then put minus sign here. Then I take a second, the first component in the first and the second column, j cap. It is, when it is taken, we have to leave this column and this row. Okay, and these four are left. They need to be multiplied. I multiply Ax with the Bz minus Az is multiplied with Bx. Okay, I hope you have understood. Now, for the third one, take this k cap. When I do so, I have to leave this column and this row, now containing k cap. So what is left is nothing but this 4. So I multiply this 2. Ax is multiplied with By. Then minus sign. These two are multiplied together. Okay. Ay is multiplied with the Bx. This is what we get at the end. It provides us the cross product of the components of vector A and vector B. Now here, if you want to replace minus sign with plus, then what you need to do? You need to just change the position of Bz and Ax. In the place of Ax you will write Bz, in the place of Bz you will write Ax. And the same thing has to be changed here. Okay, I hope you have understood. Now I will show you few more properties of vector product. If two vectors are represented by adjacent sides of a parallelogram. What is this parallelogram? Parallelogram is nothing but a diagram whose sides, opposite sides are parallel to each other. Now it appears something like this. What is shown here is nothing but a parallelogram. Here if you see, the opposite sides are parallel to each other. These two are parallel to each other. In the similar way, these two sides are also parallel to each other. But it is slightly different from a rectangle. In case of a rectangle, though opposite sides are parallel, along with it, the adjacent sides are perpendicular to each other. But here, opposite sides are parallel, but the adjacent sides are not perpendicular. Okay, so such kind of a diagram in which adjacent sides are not perpendicular, but the opposite sides are parallel, we call it as parallelogram. Now, if we represent two vectors along the adjacent sides of parallelogram, then the area, this area gives the cross product. Gives the cross product. The area gives A vector cross B vector. Cross product of these two vectors. Okay, this is the ninth property of a cross product or a vector product. Clear? Now next, if it is split along the diagonal, then we get two equal triangles. Now suppose I take a parallelogram and split this into two along its diagonal. Then what I'll get is nothing but two triangles of the same kind. Okay, this is what I obtained. And here the triangle I obtained will have area equal to half of the magnitude of A cross B vector. A vector cross B vector. Here this line represents the vector A, and this line, which is just parallel to this line, it represents vector B. Understand? So these are some of the properties of vector product. Now I will give few examples of vector product that we come across in physics. Examples of vector product. The first one is torque. Torque actually gives the degree of rotation of some object. To what extent something is rotated is given by torque. It is represented by letter tau. Tau vector is the cross product of position vector and force. The second, we have angular momentum. Angular momentum is nothing but L vector is equal to R vector cross P vector. The P vector is linear momentum. When it is multiplied with the position vector, we get the angular momentum. Third, we have is nothing but linear velocity. Linear velocity. V vector is found to be equal to omega vector cross R vector. So these are some of the examples of vector product. I hope the video is useful. If you have any kind of doubt relevant to the topic, can you put a question in the comment section. Thanks for watching.